All right. So thanks, Frank. Thanks for the intro, and glad to be here. And I'm thankful to the MemWorge team and for organizing this CXL forum, as always. So the latest update from our side, before I dive into CXL specific items, is that we are now part of Broadcom officially. Broadcom closed the acquisition of VMware, I think, end of November. And since then, we have been a wholly owned subsidiary of Broadcom. And But our charter's the same, which is we continue serving our enterprise customers with virtualization solutions, and we continue to innovate on newer hardware and newer operating system features, and we continue to enhance our platforms, and definitely CXL is one of them, and we have been hard at work with CXL as well. And this presentation is all about some of the things that we are doing with CXL as well. And just a quick disclaimer, some of the things are confidential. It's not public yet. So I please request you to refrain from sharing it in the public. So, but this sort of provides you with a roadmap view of what we are doing. So again, I represent product management at VMware, and I work on the platform side. So let's quickly talk about the problem statement. So essentially, what we are seeing across our enterprise customer base is a few issues or pain points. So customers report that they are spending too much on their DRAM memory. They are seeing sort of this imbalance between the CPU and memory usage. So most of the customers today, for example, report that they have spare cores of CPU, or they have CPU that remains underutilized, and they would like to see their CPU better utilized. Plus, the fact is that a lot of our customers actually deploy memory with certain forms of insurance, which means that when they purchase or when they actually configure their system, they actually keep some memory aside and over provision, which means that for any peak demands, or for cases where the system actually runs heavy loads, they need this extra capacity so that they don't run into heavy performance problems for their customers. So what customers tend to do is they tend to purchase this extra capacity of DRAM. Now, the issue is that, for the most cases, this DRAM is well utilized, but they do face a problem of, for example, 90% of the times this DRAM is sitting idle or not used, not really used. So VMware has been working on software memory tiering, and now we are actually also looking into some hardware-based solutions. And our solution to the problem is sort of create a layer in our virtualization stack. So basically, we'll implement some memory management schemes that will do active, hot, and cold page replacements. That will ensure that the most active memory always sits on DRAM. And the reason for doing this proactively is to make sure that most of the workloads continue to run without any drastic performance degradation. So what customers get as benefit is they are able to now utilize their more expensive DRAM component more efficiently, and deploy their lower performance or non-active pages or non-active memory onto the second tier. And again, this is entirely handled by the VMware stack within ESX, and customers do not have to change their VM workloads or container workloads to be able to make use of this. The other key point which I highlight here is that what we have seen across our field is in terms of active memory usage, it's typically around 50% for our customers, which means that whenever customers run their workloads, their locality of reference or the most active pages typically are sit within the 50% range of the overall memory. So they might actually allocate close to 90 or 100% of their overall capacity. But in terms of at any point, how much of memory is actively being used for their workloads or what the CPU is accessing is going to be in the 50% range. So it's another thing that memory might be scattered all over this range, and VMware will ensure that it brings the active memory back into the DRAM so that DRAM can continue processing. So again, the key point is that customers get a very good TCO reduction with such an approach. Plus, they don't suffer from any performance penalties. So going forward with my TCO story, here is a sample, of what we see in terms of potential TCO reduction for our customers. So if you look at the left-hand side, this is the typical 2 terabyte DRAM, DDR, socket attached DDR, and the corresponding cost. And this cost have been derived from a popular, OEM. And, it comes to this total cost. Now, we do have a form of software tiering that we are utilizing with NVMe. Although this is not CXL, but we think that the same things are being leveraged or being planned to be leveraged for CXL-based technologies as well. So we are, basically taking steps here in terms of first supporting, a known NVMe protocol and then going to the CXL. So with NVMe, what we see is if we deployed, sort of a 3:1 ratio, 3 parts of DRAM and 1 part of the lower cost NVMe, and taking, dollar per gigabyte sort of cost for NVMe, we get some cost reductions. But even further, when we get into the CXL world and start utilizing an accelerator, we actually start seeing much better performance, much better, TCO reduction, right? So if we are working with some vendors right now, of course, VMware division doesn't produce hardware, so we are working with some vendors. And essentially, the idea is we will use them, will actually work with them, partner with them, and have sort of a hardware software co-design methodology where we can get further improvements in performance and even further improvements in the total cost. So the key takeaway is that, as we evolve from going from a pure software-based approach to a hardware software co-design, we'll start providing customers more benefits in terms of cost reductions. So this is basically, what we see in terms of our evolution towards the future. So we see a lot of, activity around AI ML kind of workloads and, need for bigger memory and how a larger capacity, a faster memory could actually help some of the recent changes in AI, ML, and analytics type of workloads. So today VMware is on a journey to enable CXL in the platform, and we will be supporting CXL 2.0. And starting from Granite Rapids, VMware will officially launch our CXL 2.0 based, support. So what that means is that vendors could actually bring their devices and start enabling them on ESX, right? But there is only specific configurations that VMware will support, because we believe that will be able to provide. Again, this is based on the return or the benefit, the value for the customer. The best value is to support a specific configuration which is simple to deploy, plus it will give the minimal amount of changes, both in the software and hardware ecosystem, to be able to provide CXL. So we'll support CXL memory expander vendors and CXL memory expander devices, and customers will be able to see larger capacities. And going forward, soon, in the next few releases, we'll also be starting to support the Type 2 accelerator. This is the one where I mentioned about the hardware software co-design, where we work with third-party hardware vendors and start supporting a custom accelerator where we have VMware's IP actually running within the card, and basically doing an integrated sort of memory tiering between the host kernel and the device. So some of the benefits of doing this is that we already demonstrated that we could get some vMotion performance improvements. For a lot of our customers, vMotion is an important application. So we'll be able to see some vMotion performance applications improvements. We'll also be able to move to sort of doing some initial pooling and disaggregation. We'll also be able to do some edge type of deployments with the accelerator, and support larger AI model and AI ML kind of workloads, and also start looking into some offloads, where we could potentially offload more than just memory, right? So but primarily this device will be used as a memory accelerator device, where it will be able to work in coordination with the host and ESX kernel to provide faster, better memory usage. And finally, we have this concept of a memory pool where we will use traditional Ethernet fabric, and we'll be able to use these type of accelerators in this fashion and create a logical pool. The idea is that this will involve lower lift and shift for customers. It will even provide better security and a simpler blast radius, in the sense that we don't have to worry about customers losing an entire memory appliance, etc. So we will be providing support for such configurations in the next 3 to 5 years. And basic idea is that now we can have configurations where hosts can access multiple such devices, or multiple hosts can access a single device across the network, and everything would be transparent to the host and the VMs running on top of the host. Basically, the host will handle the memory management part, and VMs and containers, the applications on them, all workloads will continue running unmodified. So we already have a system DRS, which is our distributed resource manager, and this will manage the memory across these multiple hosts. So at a high level, how does our Type 2 accelerator look? So we'll provide a single memory address space to our VMs and containers to our customers, and they will be able to consume memory as before with no changes. So they will just have to use a hardware PCI form factor device, and it will attach and talk CXL protocol with the host. And again, this is something we are planning for the Granite Rapids and onwards time frame with the Birch Stream platform. And here are some of the advantages that I list. Basically, use of an accelerator, and as you probably have heard from some of the earlier speakers, there is definitely a lot of advantages that the CXL protocol itself brings. Not just from a CXL.mem side of things, but further with a lot of the other nice features that CXL brings, such as being a memory controlling function, and being able to track memory on the host, etc. So those things are all brought together with the accelerator. Again, as far as the customers are concerned, this will be a black box, but VMware will have its IP and it will integrate it with the ESX kernel. So in terms of the benefits, again, the idea is to provide lower TCO for our customers, and better CPU core utilization, so that with the larger memory, cores are better utilized, and customers don't have the imbalance that I mentioned. We'll also be able to reduce some of the OpEx costs. So host evacuation and memory management across hosts and pooling and failure probabilities. Those things would be handled by some of the resource management components within ESX, and they will lead to an improved OpEx as well for customers. And again, we'll continue to evolve this model and support more future use cases with pooling and sharing, even supporting some form of standard memory usage on other hosts. I mentioned AI, ML, for example, and analytics, and we could do some really good host application or workload-based analytics, and support for those workloads. And we will also be able to support, as we go, sort of CXL becoming a medium to support hardware virtualization. So think that not only memory, but we also start supporting some of the IO devices, such as networking and storage IO devices. Okay, so let me try to answer this live. What is the latency that Ethernet fabric introduces on the CXL memory? So it can range, Luis, anywhere from 10 microseconds to 80 to 100 microseconds. But we believe that if we perform the tiering really well in terms of moving hot and cold pages and tracking it across hosts, and in concert with the DRS algorithm, ensure that we manage the resources well and the workloads are moved to the right host that can support the latencies, we will be able to support that kind of latencies with the Ethernet. So we are continuing to do more experiments. We'll be running more workloads, and we'll be determining what type of workloads actually suit this model. But so far, our experiments have yielded pretty good results, and even our most recent benchmarks are showing some really good, promising results. And the accelerator is itself being built, keeping in mind the need for doing networking across hosts. So David, are type 1 accelerators going to be supported on current generation CPUs or only with Granite Rapids? Um, David, type 1 accelerators will be supported only going forward with Granite Rapids, simply because we wanted to make use of some of the enhanced CXL capabilities with CXL 2.0. CXL 2.0 provides much better RAS capabilities, and we believe we are also working in conjunction with some of the vendors and OEM partners who are actually aligned with us on supporting this with CXL 2.0 and with some of their platforms on Granite Rapids. Okay, so let me see. So in terms of the differences between NVMe tiering, which is sort of, you can consider both of these solutions sort of orthogonal, um, in the sense that it will mean slightly different things to customers. So NVMe is just about plugging in an NVMe drive into an existing host and enabling software-based tiering. So it's a very simple approach. Customers can just take their existing platform. They can actually plug in an NVMe drive, and they will start seeing memory tiering being used. We will also be providing some statistics, some information on how the memory tiering is looking for the customers, so that if they start seeing performance issues, they will be able to adjust their tier sizes, or be able to trigger moving their workloads to other hosts using vMotion, etc. In terms of the TCO, it will provide lower TCO benefits, just because we will not be tiering a whole lot into the NVMe, and we do recommend lower tier sizes on the secondary tier. With the accelerator, we are hoping that customers are able to tier up to 100% of their DRAM capacity. So it will basically be a 1:1 tier with the accelerator. And in case of workloads, we believe NVMe-based tiering is sufficient for VDI and VM consolidation, general workloads that are more IT-like workloads. Whereas with the accelerators, because this is CXL-based and it uses some of the good properties of CXL protocols, we'll be able to support a much better variety of workloads. So NVMe has higher latencies with CXL protocol and memory caching. We'll be able to provide better support and a superior solution. So there is some CPU cost. The host CPU will perform tiering, whereas with the accelerator, we could move some of the processing to the accelerator device itself, so that we put less of a burden on the host. Now let me see if there are any more questions. Okay. Why do we, so the question is, why do you want to connect through Ethernet fabric when CXL supports switch and GFAM, which is better in terms of latency of CXL memory? Yeah. So Luis, the way we are looking at this is to see what our customers can do as an evolution. So sure, CXL fabric will evolve in the next few years, and we want to watch carefully how it evolves. And we don't want to force customers to move into a complete CXL fabric-based approach. We want to start them with an Ethernet-based approach and see how it goes. And maybe in the future we will support CXL-based fabric for our customers. But at this point, we don't really have that as something that we are seeing immediately, but maybe our views will change in the next 2 to 3 years, where we start customers actually adopting some of the CXL fabric and doing some actual work with implementing CXL in their environment. Of course, having said that, there is actually a division within Broadcom that is, I think, I believe it's our PLX division that's actually building a CXL switch, and we would want to see how we could collaborate, and maybe there is an opportunity there for the VMware division to work with the Broadcom division that's working on the CXL switch. Does the client need to be running VMware to get memory tiering? Okay, this is a great question, actually. Initially, we are building these with VMware ESX in mind, but I didn't mention that eventually we want to actually move or evolve the accelerator into a device that could become a general purpose device, and which means that it could actually have work with a host that actually might be running a Linux or a Windows even. So yes, actually this is in the plan, and we do want to make this device. You can think about it as a hardware-based hypervisor or a virtualization device. So let's see. Okay, I hope I answered all the questions. So this is my last slide. So essentially, the summary is VMware will support CXL expanders in specific configurations. And again, this is CXL 2.0. We'll be starting to support this from the Granite Rapids and onwards. We are actually working with OEMs and some of our CXL vendor, CXL memory partners very closely on this. Memory tiering is definitely something VMware has invested a lot on over the last few years, and we want to continue doing that and bring out some new solutions that utilize memory tiering. And then finally, memory accelerators. So this will be our sort of our complete evolution to CXL-based usage and CXL support, where we'll have customers actually getting a lot more benefits with CXL-based accelerators and enabling. So if you have any questions, and any interest, I see that there might be some customers in this forum. Please don't hesitate to contact me. I think we are certainly interested in partnerships. POCs or demos can also be arranged, and we are evaluating solutions right now, with different technologies. So we would definitely be, I would definitely be interested in having conversations with customers on seeing how we can benefit our customers. With that,
Arvind, there's one more question.
Yeah. So Luis is asking, is the ecosystem ready to push part of the processing in the type 2 accelerator and partition between host and accelerator? So the question is if the CXL ecosystem is ready. Yeah. So Luis, my experience has been that the ecosystem, CXL is pretty open. It's an open standard, and customers or vendors and designers will start coming up with creative ways to use CXL accelerators and CXL-based devices. And, it's really more about how you actually can, make sure that this is all seamless to customers. So as long as this is seamless to customers, we believe that customers will use it. And then our OEMs and other partners will fall in line to be able to use such solutions. Because in the end, it's anything that benefits the customers is what will bring sort of the pull towards getting these solutions into the market and get some adoption. So with that, I think I've taken my time. Thanks a lot, and definitely enjoyed this question answer session. And looking forward to further sessions with Memverge and the CXL forum. Thanks a lot.